Okay, so quick introduction. My name is Shaun Smith. I work at Hugging Face on our MCP server. I'm a part of the MCP steering committee, and I'm on the transports working group. I also maintain a tool called Fast Agent. And today we're going to be talking about the options you've got for deploying Streamable HTTP, so the transport that was introduced in March. Looking at how sessions relate to that, and then looking at some statistics and how clients behave and so on from what we've seen on the Hugging Face server itself. And just a quick word on the Hugging Face server. So the Hugging Face server gives people access to the hub, which, as you know, lets people search for the top trending models or finding details about data sets. And the other thing that you can do is connect to thousands of Gradio applications, which are machine learning tools, image generators, inference engines, all kinds of amazing stuff. So part of looking at part of running this service, late August, I saw a very sudden and catastrophic traffic drop, which concerns me hugely. I'll leave it there for the minute as to what actually happened, and we'll talk about what did occur. So when I was at this summit in May, one of the things we kind of mentioned was how easy it was to just have MCP servers and hosts plugged together, and everything kind of just worked, and that was what made MCP really popular. And now we've seen a lot of remote MCP servers come together. And one of the things which isn't immediately obvious about Streamable HTTP is the number of options you have and the configuration that it needs to get it working well. So the very simplest server, and if all you need is tools, prompts, resources, and completions, can just do a straightforward HTTP request and response. Yep, so the host application sends a JSON RPC packet up to the server, you get an HTTP response, and it just works. Thing to know, the default setting in the transports is not to do this, right? So if you want to have this behavior, where you just do the request and response, you need to do the example for the TypeScript SDK is there. You need to say enable JSON response is true, which is what that setting does. But obviously that limits you somewhat because there's other features in MCP that we might want to use. So the next step up is if you want to use progress notifications. So if I want to use tool progress notifications, when I receive the request from the host, what I actually do is I open up an SSE stream in response, send a sequence of notifications, and then send the final response, and then close the stream. Okay, and this is really useful, like particularly if you kind of think about on Hugging Face, we might get a new model from Black Forest Labs or something to generate an image. So we kind of want to give people an update. So I'll just give a quick demo of both of these things. So on the left, we've got a copy of the Hugging Face MCP server pretty much as it's configured in production. And on the right, I'm connected to that MCP server, right? So if I just check who am I on HF, then it runs the tool call. It says I'm authenticated. And if we look at the actual tool call response, you can see that it's come over HTTP JSON RPC. Yep, so the tool's run in sort of a couple of hundred milliseconds, probably less than that, and we've just closed the connection. Slightly more bravely, we'll see if we can get this one working, is use Schnell to make a kitten image. So, yeah, so this time, so it's identified the tool, and if we look at the bottom right here, so it's probably not best for looking at for the audience, but on the bottom right, you will have seen a set of progress notifications come in, and so we can keep the user updated with what's happening. And ideally, we would also reset the timeout counter whenever we got one of those notifications. Because if we didn't reset the timeout counter, the original post request would time out and stop working. And just if we kind of want to have a look at that, we can see my first tool call came in over JSON, and the second tool call came in over SSE. Yep. So as the MCP server author, you have that optionality. You have to choose which of those two things you want to do. So up to now, then, this is all actually very, very straightforward. We simply need to make that decision when we get the request. Now, as we know, MCP is actually bidirectional. Yep. So it's not just the case that the host makes a request to the server, because normally when we talk about clients and servers, we think the client makes a request to the server, and that's the relationship. But in MCP, we also have the relationship where the server can make requests back to the host. So, for example, in the case where we are wanting to, if the MCP server wants to do an elicitation, which is basically going to pop up a form and ask the user for some information, and the way that works is we send the request, we open up the SSE response stream, and then what we actually do is we send to the server, sends a request from the server to the host, and the host then services that. So you fill in the form, and then you do another post to send the form data, the elicitation result, back to the MCP server, and then the MCP server gives you the final tool call response on the original SSE stream. Got that? Yeah, it's a bit of a dance, right? There's a few steps. So I'll just talk through this. So what I've got here is I'm now connected to the everything server. So this is one of the MCP servers that we maintain. And basically it's got functionality that kind of exercises all of the protocol. So with the everything server, I'll just check that I am connected. Yeah, and we can see nothing's happened yet, but I'll say use the elicitation tool. So that will send the post. I get the response on SSE, which then displays the form, and I'll say red 99, accept. So again, we can see we got the response on the SSE stream, and if I then look at how that arrived, yeah, I can see that yellow diamond is showing me that I actually got a request from the MCP server that I then needed to handle. Yep, so when we've got an associated, so if we've got an elicitation or sampling request associated with a tool call or a prompts list or a tools list, we should associate it with the stream that it came in on. So, and again, that's something that in the SDKs we need to make sure actually happens, because otherwise we'll end up with the notifications going to a different channel that we don't necessarily want. So this gives us a kind of a new set of things that we need to worry about. We've then got the final kind of final aspect of this, which is we know that MCP servers may want to initiate things with us. Okay, so they may want to do a sampling or elicitation request which hasn't come as associated with a tool call from the client, or we might have a tools list change notification, or something like that. Now, what we're now kind of having to do is, once we've initialized our MCP server, so the first thing that an MCP server does when it connects is send an initialize, shares a session ID and goes back. We then have a get channel open, which we can then send these unsolicited server to client communications on. And so that get channel is the thing which then which allows the MCP server to initiate that communication. Another thing which, I don't know if anyone here has read the transport spec. I still don't know if there's not seeing many nods. It's not actually within the transport spec. It's one of the utilities, but we should also make sure that the connection is kept alive using pings, right? So host applications can connect to the MCP server, send it a ping to make sure it's there. And if we've got this get channel open, then the pings are returned. The pings from the server to the host come from the get channel, and then we can service those pings, and the server can tell it's alive. So I'm going to do a kind of a final demo of that. So there's me. So I've got this webcam MCP server. If I just look at the connection statistics, yeah, we can see that the webcam server has been pinging this get channel to keep it alive. Because one of the problems with having the host application do a get is that if it's not kept alive, it will disconnect, and often it will silently fail, right? So there's quite a few places where you get silent failures in the SDKs that you need to be aware of. So again, for diagnosis, I would kind of make sure that you could see this. So this will then run a sampling call. So this button will send the image over here. Yep, so it's now doing the sampling. Comes back, tells me what it can see. And I'm thinking that I probably should have adjusted the system prompt to make it say something a bit more flattering about me. But that would have been good prompt engineering. But as you can see, right, so rather than the request coming in on the post SSE stream, because it was initiated by the server, because I pushed the button, it's been sent over the get SSE stream. Yep, so there's a bit of kind of engineering that we need to do to get that working, neatly. So I'm not going to talk through this slide. That would be absolutely horrible. You may want to just take a quick picture of it, and obviously we'll make these slides available afterwards. But in terms of those options that we've got, here are the capabilities that you can support with them, right? And I'm going to be honest, right? This isn't the concluding part of the talk. But if this is all you need, you are absolutely golden, right? This stuff works brilliantly. It scales horizontally. You're in a really, really good place. If you need that other stuff, there's a few other things that we probably need to talk about as well. So when we looked at that initialization phase, we saw that a session ID was allocated during that handshake. Now, the session ID is embedded within the Streamable HTTP Transport. Right, so obviously with MCP, we have the protocol itself, which is a bunch of data structures and JSON RPC envelopes. But MCP session ID doesn't live there. MCP session ID lives within the HTTP transport layer. We don't have an equivalent in standard I/O. So it's very closely related to it. Now, for us, right, and I think probably for most people writing MCP servers, identity is going to be managed by the OAuth login or an API key or something else that you've got for servicing back-end APIs. So for us, we manage 0 GPU quotas, these spaces you've got configured in the proxy server, and all of that kind of stuff. So the session ID is very, very tightly coupled to the transport, right? It's not part of the data layer. So what can we use the MCP session ID for? So, and this is a challenge we have with standard I/O servers as well. And I'll try and kind of talk through this flow. If I'm writing a host application connected to an MCP server, and I allow, for example, multiple chat threads, should I have an MCP server instance for each chat thread, or do the chat threads share an MCP server instance? And if I've made a connection, what does that mean for my session ID? Right, so the MCP session ID, it's not a chat ID, it's kind of like a connection ID. And the challenge then becomes that if I've got a multi-threaded chat application on one MCP server, and I say I'm on the staging database, you can probably follow this. Hopefully you can kind of follow that flow, right? Which is that I open up one chat window, it sends a bunch of MCP commands. I open another chat window, it sends another bunch of MCP commands to the same server. And if the server has state, there's the possibility that if I were to switch back to the original chat, I could do something quite undesirable. But the point is, right, is some MCP servers would benefit from this. Some MCP servers would not benefit from that. And we could probably have a long dialogue. I'm sure a lot of people will say, but if you fixed it by always sending the database key, if you fix it by, yeah, I know all of these things, right? But what we haven't done is made this intentional, right? So we're very, very keen as part of the Transports Working Group to make this behaviour intentional so that we know and can choose what behaviour we think is right. What is useful to know is a couple of months ago, we were talking about this in the Discord. The VS Code team have chosen to go down the one transport per chat route. Right, so I open up a new Streamable HTTP connection per conversation thread. So the other challenge then, right, so when we think about, we did that elicitation earlier and you saw me fill in the form. And so what I then need to do is post that form back to the MCP server, which in a normal threaded model is going to be sitting there waiting for the result before returning the response. Yep, so again, in a kind of a normal SDK usage scenario. So what we need to do then is make sure that that response goes back to the right server. Yeah, so in a load balanced environment, if one server has sent the request and is waiting for the response, if it doesn't go back to the correct server, and I haven't got some very, very clever sort of message pumping queuing system in the back end, I'm not going to know it came back. It'll have gone to the wrong server. There's a slightly more subtle and potentially more serious issue than that as well, which is that because the SDK by default monotonically assigns request IDs, even if I've kind of distributed my MCP session state, if I haven't also managed my JSON RPC request and response IDs, I could end up sending a response to a server and not correctly associating it because the JSON RPC IDs themselves weren't properly unique across the cluster. So again, this is something that is, if you want to do this, you will need to adjust the SDKs quite significantly to work at scale. Yeah, so this is a problem that we need to get right if we want to use that bidirectional communication. Yeah, so I spent hours on this animation. Well, actually, Claude Code spent hours on this animation. I wanted to run it twice because I didn't want the effort to be wasted. So what caused the huge traffic drop? So I was terrified, right? I'm thinking, what on earth have I broken? What's gone wrong? And then, of course, when something goes wrong, you open up x.com to find out. And this was the answer. So like within hours of me seeing this gigantic traffic drop, I saw this from Alex Albert, who's the Claude Com's team, or yeah, he's the PR guy for Anthropic. And yeah, so actually what he said was, we've tidied up a few rough edges in Claude. And I went, perfect, because what we're seeing on our MCP server is, and I was trying to think about how best to present this data, so I've done it as ratios, right? So the traffic we really, really, really care about are tool calls, because a tool call means that someone has intentionally done something and they're getting value from running a search or so on and so forth. But with MCP, we obviously see a lot of other MCP method calls to do prompts list, resources list, and so on and so forth. And what we're actually finding is that for every one initialization event, we see 0.03 tool calls. Claude is one of the biggest. Hosts. Well, in fact, it is the biggest host that we service. Prior to that tweet from Alex, we were seeing a ratio much, much lower. Right? So put another way, for every 3 valuable tool calls that we get, there's 100 initializes. Okay, that may or may not be surprising. We'll look at that in a second. For every 165 MCP method, for every single tool call, we get 165 MCP overhead calls. Right? So this is quite a chatty protocol. Some of this you would expect, some of it you wouldn't. What I would like to have been standing here saying is that because we don't advertise the resources capability, we didn't see any requests. But sadly, that isn't the case. We see lots of resources requests. But we'd sort of expect this, right? Because for a lot of interactive applications, people install the MCP server, they go, this looks like a good idea. And then they'll sit there, they'll use it for a couple of hours, and maybe they'll do a tool call, right? That would be normal user behavior. And actually, there'll be quite a few sessions where maybe they connect and they don't use our MCP server at all, but they would use it in the next session. They're probably not going to unconfigure it. So that's not necessarily bad in itself, but it is something if you're deploying MCP servers, you kind of want to be thinking about, if, for example, I'm expecting to allocate a get SSE handler to everything that connects to me, am I really going to have an opportunistic SSE handler sitting there in case the tool list changes? I don't know. I mean, that might be your use case. I can sort of talk about running this server publicly. But it's bimodal. So we either have clients that behave that way, or we have clients that come in, trigger a burst of activity, and disappear again. And so those clients will normally be things like if you're using the remote MCP functionality in the OpenAI inference API or the Anthropic inference API. Grok have recently done this. And to be honest, I quite like those clients because they just come and go, right? They do their job and disappear. So this is a slice of our current usage. So looking at, to be honest, right, the count of sessions is around about 1.5 million, and I chose the data set because it was convenient. I know that this is very, very representative, right? So if this was 3 million from a few weeks before, it would be basically the same. And this is basically showing us what clients connect, but this isn't done by the number of initializes, right? So in terms of the overall profile, there's a huge long tail, right? I've seen well over 500-600 client strings. And you have to tidy up the data, so I don't know if anyone from Postman is here, but please stop putting a GUID in your in your client name identifier, right? This stuff just makes my life harder. So there's a bit of cleaning you have to do on the data. So again, this isn't looking at the raw count of sessions, this is looking at the hosts that use the server. Yeah, so if you make a tool call, you're added in this list. If you just connected and disappeared, you're not added to this list. A couple of interesting things. Do not rely on host applications sending you deletes, right? They just don't do it, right? So they don't tidy up after themselves. So I wouldn't rely on that behavior. We see an awful lot of, well, I say an awful lot, we see a few clients which send us invalid capabilities. So the most common issue that we see there, and the biggest one there is actually Cursor, is they send us MCP server capabilities in the client capability string. Well, it's not a big deal, but it's kind of worth knowing about how you're handling those capabilities. And again, looking at that data slightly differently, if you were to look at the raw count of initializations, only 1% of clients support sampling, right? But actually, when you look at people that are using the tools, then about 22% of tool uses come from a host which supports sampling. Yep, so we're seeing this come up. One of the other things, I can't remember if I left it on the slides or not. One of the things I was going to say was when we first launched the server, the biggest host that we saw connecting to us was a tool called MCP Remote, which enables standard I/O. Enables you to use Streamable HTTP servers with standard I/O. But the usage of that has dropped really, really low to the point where for this presentation, I didn't even need to massage it in the statistics, but it used to be incredibly popular. So just a couple of sort of thoughts to wrap up. If you want to play with this, right, and so the Hugging Face MCP server, it's open source, you can deploy it in a completely stateless configuration, in a stateful configuration where it supports tool change notifications and that kind of stuff. It's quite a good testing ground, and you can deploy it on a space, like it's one line of Docker, and you can just have it running and fiddle about with it all you like. The developer experience in the SDKs for how you use the different transports, so even within Streamable HTTP as a server author, depending on if you want to be stateful or stateless in how you do things, the SDK experience is quite different. So, and again, if you kind of look at the Hugging Face code, you'll see there's various forks and places where we've had to change things. Because what I wanted to do was use the SDK as much as possible. I didn't want to be working at the JSON RPC wire level. And honestly, I'm not sure if that was the right choice, right? Working at the JSON RPC wire level for some of these things probably does make sense. Oh, I did say about MCP Remote. If you're in complete control of the host, the server, and the client relationship, I think you're probably going to, if you want to use these server-to-client features, I think you'll be fine, right, if you've got complete control of that. I think in a public environment, that's going to be tough. Handling those GET connections in scale-up, scale-down environments, dealing with connection breakages, it's quite hard. I'd say think about if you absolutely need those features right now, and if you think, yes, I do, that's really cool, really think again if you're in a publicly deployed environment, right? Because it's a lot of experience to try and manage. I think the talk before MCP UI was saying about kind of owning that user experience. And again, looking at the current client implementations, I would only use elicitations for low stakes things. We're only supposed to use them for low stakes things anyway, but actually when you kind of think about about some of the user experiences there, that might be something that most people don't want to think about. So as part of the transports working group, the kind of the things that we're sort of trying to look at is, as we mentioned, talked about the GET handler. We talked about the MCP protocol overhead. It's all right, I'm just aware that lunch is about to be served. So, everyone's just going to leave anyway. Timeout handling behavior is tough, right? Because if your host isn't resetting timeout windows based on progress notifications, if I've got a tool which takes 35 seconds, but the post-SSE timeout window is 30 seconds, even if I'm sending notifications, it just terminates on the host side anyway. There's nothing the server author can do about that, right? So these are the kind of challenges that you're going to need to think about. Yeah, and so finally, as part of the Transports Working Group, come join us on the Discord, come tell us your experiences, tell us where this doesn't make sense or where this isn't right. The kind of the big one we're talking about at the moment is actually making MCP stateless by default. And I want to just quickly spend 1 minute talking about what we mean by a stateless protocol, because we're not saying that we shouldn't have host and server applications which know about each other and maintain state. What we're saying is that if we've got that initialize handshake at the start, what we would prefer to do is to, rather than have the initialize handshake, is send the information that's in the initialize handshake with every request and response. That's it. So when we're talking about making the protocol stateless, we're saying, actually, let's just make it so that server and client capabilities are sent on every request, for example, or the protocol version is sent on every request, rather than having a stateful initialize handshake at the front. That's it. It's not so it sounds scary, but it's actually quite a sensible thing. So we're hoping to be able to handle some of those things. So that was me. My 25 minutes. Great. Well, that's not bad. Yeah, 26. All right. Thank you.
Thanks a lot.